Greetings and welcome, friends. Imagine, what if there was like more than two dimensions? What? This is crazy, guys. It turns out there are more than two dimensions. We've been looking at geometry for so long on a plane, right? But it turns out it's existed beyond that. I won't say how far beyond. That would be some interesting questions right there. But we're going to go into a new dimension today. So get ready to pass through a nether portal. Here we go. The three-dimensional figure or solid is bounded by flat or curved surfaces that enclose a single region of space. A polyhedron is a solid that is bounded by polygons. All right, so surfaces would be things like this. This is a surface right here. This is a surface, right? That's like a curvature there. A sphere would have a surface, yeah, that you could imagine, right? That is not a polygon that is bounding that region. But polyhedron are, right, poly right there, bounded by polygons, multiple-sided figures that are two-dimensional. When their powers combine, form, at times, polyhedron. And those polygons are called faces. So here's a face. And edges, as seen, and vertices are the points in which the edges meet. Ooh, polyhedra. That sounds pretty cool. That's how you pluralize that. So here are some types of solids. All of these, solid. Couple categorizations here. Prisms are solids in which there's a base, and then you extrude it in a direction. Pyramids are solids in which there is a base, and then they edges leave the vertices of that base and converge at a point. Okay, cylinders are kind of like a prism, right? It's got a base that was extruded up. It's got two congruent bases here, right? And we just kind of like, if I pull this up, it makes a solid, whereas a cone is kind of more similar to a pyramid, except these obviously, like I already said, are not polyhedra because they have curved surfaces. And a sphere is just awesome, dudes. That's just awesome. You gotta admit. You gotta admit. Let's see, who believes the world is a sphere? Yeah, no one, because it's not perfectly spherical. Actually, that would be an interesting question. Is anything in our universe actually perfectly spherical? Yeah, not really. Actually, maybe one day I'll show you guys a video about the most spherical object ever made by man, but even it itself is not perfectly spherical. So let's see. To name a prism or pyramid, you name the shape of the base. The two bases of a prism are congruent polygons in parallel planes. The bases of a pentagonal prism are pentagons. Ooh, yeah, so we can name prisms and pyramids based off of the bases that they contain. So here is a pentagonal prism. Up here we had a rectangular prism because the base was a rectangle. And then you also name pyramids based on their bases. So here's a triangular base. So this is a triangular pyramid. You can also have square pyramids. Did we have a square pyramid up here? Yeah, there's a square pyramid. You could also have a hexagonal pyramid where the base is a hexagon, and then imagine all of those vertices from that hexagonal base have edges that converge at a single point. Amazing. Amazing. So you can classify solids with some names now, based on whether it's a polyhedron, based on whether it's a prism or a pyramid. So let's see. First of all, is this a polyhedron? Yes. What would you name this? Brian is a great name for this. I shall call him rectangular prism. Yeah. And guys, what's interesting about prisms, they don't necessarily, the base doesn't have to be on the ground necessarily. You also can extrude it in another direction as well. So this is rectangular if I view it that way. I also, there we go, prism. I also could have viewed this as a base, and I extruded it up, like so. Excellent. All right, is this a polyhedron? Friends, polyhedron? Yes, it's composed up of polygonal faces. What type of polyhedron is it? Looks like a hexagonal pyramid. Actually, I don't know if I've seen hexagonal pyramids in architecture very often. Most of, ancient pyramids are going to be like trapezoidal steps or a square-based pyramid. But, yeah. And is C a polyhedron? No. But what would we call it if we had to? Cone. I like it. I like it. Here, check this out, friends. So we can also perceive of planes passing through polyhedron. Okay, these would be called cross sections. Imagine if I went Fruit Ninja on these cubes and I go swipe, 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 right? Depending on how I swipe it, you're obsessed with Fruit Ninja? That's great. Yeah, my sons play the Xbox version of it. With Kinect, it's amazing. So here are some cubes. Notice this one over here. If I cut that this direction, the cross section I get is a square. If I cut it diagonally, I actually get a rectangle. Right there, rectangle. And if I cut this one kind of from a corner, I actually can get a triangle, and not just any triangle. I can even get an equilateral, equiangular triangle there. So that's a slicing. So those are called cross sections, which describe the two-dimensional figure you would get if you sliced the 3D solid. I was going to say in half, but not necessarily in half. Please now. Because, yeah, you could just slice it any which way you want. So, let's figure out what would the cross-section be. So, actually, someone tell me, what would this solid be called? And then what would the cross-section have been? Someone want to help? It's a prism. What's the base? Yeah, this is like one of those sideways prisms, right? It was, yeah, it fell over. So it's a hexagonal prism. And what would the cross-section be? This area here? Looks like a hexagon. Okay, someone else name this solid for us. Name that solid. Do me a solid, friends. Someone give it a name. Triangular pyramid. And this cross-section looks like a triangle, yeah. I like it. Okay, over here. What do we call this? It's a cylinder. And this particular cross-section, notice, is not a circle. It actually would be a rectangle. Rectangle. Here's a cone with a circle. Now, question, what if I cut this slightly at an angle? Would it? Yeah, you actually can get an ellipse, but the answer to this question was a circle. You can get an elliptical shape if you kind of angle your slice a little bit. How about this? This is what solid? A sphere, and this is a circle. Actually, this is called I believe this looks like this plane passes through the center of the sphere, that this would be a great circle. And I'm not just saying that because I think it's amazing, but that's actually what it would be called. A great circle would be like the equator of the planet Earth, if the Earth was a sphere, but please. It's got bumps on it, right? It's all lumpy. It's not perfectly spherical. All right, what was this solid? Ah. Ah. It's a square prism, also known as a cube. All right. And what would this cross section be? It's actually a trapezoid. I believe this one, I'm assuming, looks like it might even be isosceles. Amazing. Amazing. So guys, check this out. It turns out, because you can kind of think of solids in a bunch of different ways. Here's a weird idea that's kind of tricky to visualize at times. But you can actually create solids of revolution by taking a two-dimensional shape and then rotating it around an axis. And you would get a solid. So for instance, rotating this rectangle could produce a cylinder. All right? And this can be a little bit tricky to visualize. So I'm super pumped about this, guys. I'm super pumped. You know me. I get excited. Here we go. For example 3, behold. Here's example 3. Sketch the solid produced by rotating the figure around the axis. So what type of figure is this right here? That's a rectangle. And if I'm going to rotate it around this axis, so what I've got here is an arc that I'm going to extrude it along. Look at this. This tool, it's called Follow Me. And, let's see. Will it work? Oh, it's yelling at me. It's not happy. It's not happy. I think I messed up. I think I messed up, guys. There we go. Ooh, what shape is that going to be? Oh, wow, it's getting really scared. Rip. It's like glitching out on us. All right. But anyways, yeah, you can see that became a cylinder after rotating it. Yeah, isn't that wonderful? How about this one? Here's a triangle, and rotating it about this axis. I think you're right. Yeah, so there you go. Not bad. That's going to be a cone. Yeah, see, I'm super excited about this. You guys can see why. I set this up. I'm like, I'm doing it. I'm doing it. I'm so proud of myself. Oh boy. So yeah, one of the ways you can kind of visualize this if you're doing this en papier is kind of like, imagine if this got rotated here and this got rotated here, right, and around. You could kind of visualize like a can that you're kicking on the ground. And then if this gets rotated around this way, this point gets mapped to itself, and this would end up being a cone. So yeah, so this was a cylinder and cone. Yeah, I like those ones. You guys like it too, don't ya? Yeah, you do. Yeah, you do. All right, let's look at the monitoring progress ones for these, because like I said, it can be weird trying to visualize three-dimensional things from two-dimensional representations. What do you guys think 7's going to become? Cone. I agree. I think I agree. Right, this one would get warped around this way. And yeah, that'd be conical. Bam. How about this one here? This would actually, a tube, would be a cylinder. It'd be a can. All right, there we go. What's the diameter of this can? And what's its height? Yeah, so this is 12 wide. That's a terrible curly brace. And it's 8 high, right? Yeah. So yeah, you can describe this. All right, 9. What do you think is going to happen with 9? Oh, you guys are too quick. You're with the quickness. You like this? Yeah, awesome. Awesome. Let's see. Can I open up? Let's see. Where's my awesome sketch? Here we go. I'm going to open this one quick. Let's see. This one, usually this has a harder time with. It's loading. Here we go. So here's question 9. That's a semicircle that I'm going to rotate like so. Let's Hey, follow me as I extrude you around a path of delight. Here we go. Ah! Oh, I gotta undo it. And... kinda. Oh, it glitched. It done broke. I don't know what I'm doing. Well, like, it does get a little bit confused. See, and then sometimes even when I don't finish clicking, it gets scared. I'll just do it. Meow. Man. Yeah, and then it, like, glitches at the end. Alright, I'll just do it partially. But you get the idea. It's gonna become a sphere. Yeah. It's not perfect. This is free software, friends. I got it to work once yesterday. Oh, wait. It's like horrified of itself. That was close, wasn't it? Well, anyways, there we go. Now we got like Pac-Man 3D. So yeah, so that's gonna be a sphere. Not bad. So like today we're just like kind of talking about lots of names of things. It's not even that bad. But yeah, and it requires a little bit of visualization, but I think you guys are gonna do great. Thanks for watching, internet friends.